difference between displacement and pressure, correct?
Yes, sir.
There being a phase difference between displacement and pressure. So it goes without saying that wherever you are to get displacement antinode, at the same place you will be getting pressure node, correct?
Yeah.
You are getting displacement maximized at a place, then owing to relation that they share, pressure will be minimum at that place, right, Krish?
Yes, sir.
So what we say, we can plot the pattern of displacement or we can plot the pattern of pressure, right, dear?
Yeah. Yes, sir.
Yeah.
Here we are beginning with the premise that we will go for displacement plot. Am I clear?
Yes,
Yeah.
sir.
So we'll be looking for displacement and from there we can draw easily how will pressure displayed or feature, right dear?
Yes, sir.
Yes.
Okay. So we are having two waves. They are of same amplitude. That means the first one is being indicated by a sine of the angle omega t minus kx. Is it okay? I'm just taking a straight case. Right here, a
Yes,
sine
sir.
of the angle omega t minus kx is the first representation. So this wave, as you all know, is propagating along positive x-axis, right? It is
Yes,
progressing
sir.
along positive x-axis, correct, yeah?
Yes, sir.
Yes.
Now this is being interfered. This is being interfered and interfered in its totality. This is being interfered and interfered in its totality. That means I had a string. I had a string and I am continuously moving my finger up and down, right? Yeah.
Yes, sir.
Yes,
I'm
sir.
getting a wave trail established in the string, and that wave trail is propagating, right? Yeah. I've
Yes.
got
Yeah.
a wave trail established, and that wave trail is propagating. Fine. Now I asked Kadesh to go to the other end of string, correct? I
Yes,
asked
sir.
him to go to the other end of string and detach it from wall to start moving his fingers up and down. Is it okay?
Okay.
Yes, sir.
Yes, sir.
So what will Ades do in turn? Ades will also generate a wave which is propagating in the direction opposite to the one which I have made propagate, correct?
Yes, sir.
Yeah.
Yes.
Now what will happen? That is what is the question. That is what we are to study today. Got it? Yeah.
Yes,
That is
sir.
exactly what I'm to study today, which is what will happen? What will be the pattern seen now? How will the string move now? Getting it?
Yes, sir.
Yeah.
Yes, sir.
Where are the two waves getting established? Where am I actualizing? I'm actualizing my wave on the rope. Correct? Yeah. So is
Yes, sir.
Adi. So is Adi. The only difference, I am making it propagate along positive x-axis. This is propagating along negative x-axis. They are getting superimposed. They are ought to get superimposed. Why? They are moving on same rope. They are moving in the same medium. Correct?
Yes, sir.
Yes, sir.
Okay. So our study is to be limited to what pattern we will see of the rope. What will be the rope into display? Am I clear?
Yes, sir.
Rope as in here, medium. Correct?
Yes, sir.
Yes, sir.
Rope as in here, medium. Parts of rope as in here, particles of medium. Getting it?
Yes, sir.
Yes, sir.
Okay, good enough. So let us try to now substantiate it in black and white. What we will see, let us try to first substantiate in black and white And from there will stem the shape, nature of shape. Let us take the two waves as indicated. One of the wave being a sine of the angle, omega t minus kx. This is first wave. A sine of the angle omega t minus kx to us. And let us say the other one is a sine of the angle omega t plus kx plus certain initial phase difference beta. Got it, yeah?
Okay, yes, sir.
Yeah.
There is one initial phase difference between the two waves, and that is indicated by beta. Got it, yeah?
The
Yes, sir.
amplitudes are the same.
Okay, yeah, dear.
So the
Amplitude is same. Amplitude is same. Okay? Just there being difficult, we will have difficulty facing getting two waves which are in phase. So generally what we do, we introduce beta. You see that beta later is not to hold water, and I'll prove it. But I'm beginning with what is generic. So there is a phase difference between two waves, and that is a what quantum, dear? Beta. Got it, dear?
yes,
Yes,
sir.
sir.
Now they are getting superimposed. One wave from this side, the other wave from this side, they are getting superimposed. So as per principle of superposition, tell me what will I write simply? What is principle of superposition to say? That a wave has got nothing to do with what the other wave inflict on particles of medium. Say yes or no?
Yes,
Yes,
sir.
sir.
So the effect is independent. They are alien to each other on effect. Correct? They are immune to each other, right? Yeah.
Yeah.
Yes, sir.
So what will I do? I'll add them. Simply, we are to add. And you know when you add what you are to get. Yes, please. When you add what you are to get. These are trigonometrical function. Recollect your 10th standard formulae set. Recollect your 10th standard formulae set. And tell me what will you be getting? Sine A plus B plus sine C plus D. Got it, yeah?
Yes, sir. Remember, sir.
Okay, so what will that get you? 2A
Sine of
sine
the
of something.
sine
Sine
of
kx
the
plus minus beta by 2 into cos of the angle omega t plus minus beta by 2. I'm taking all the possibility, therefore plus minus. Got it, yeah? Because one
Okay.
may say, I will not take beta associated with second wave. I'll take it with the first one, right?
Yes, sir. Okay.
Yeah.
Yeah. So I'm taking all the possibility in my foray. Therefore, what we are to end up getting is 2a sine kx plus minus beta by 2 cos of the angle omega t plus minus beta by 2. See, please don't quarrel with anyone who is to say that no, I will not take this one. I'll go with a sine of the angle kx minus omega t and a sine of the angle kx plus omega t plus beta. Why I'm asking you not to quarrel with him or her is because they differ by what you know. They differ by an angle pi, correct, yeah?
Yes, sir.
Yeah.
Them differing by angle pi. So we have taken all in our stride by writing plus minus beta. Got it, yeah?
Okay, yes, sir.
See, be
Yes.
very frank with you. When you will take this, you will get this one. If you will take this, then you will get sine of the angle omega t and cos kx. Is it okay?
Yes, sir.
And you
Yes,
please
sir.
know it because I can repose faith on you at least know sine of a plus b plus sine of c plus d is to get you what? Correct, yeah?
Yes, sir.
So if you will take this and this, then you will end up getting 2a sine kx plus minus beta by 2 cos omega t plus minus beta by 2. Clear?
Yes, sir.
And if you will take these, then you will get 2a cos of the angle kx minus beta by 2 sine of the angle omega t plus minus beta by 2. Clear? Yeah?
Yes, sir.
Okay? I'm not laying much credence. You will get to know in 2 minutes from now. Fine, dear? So
Yes.
going,
Yes.
is it okay? You'll get to know
Yes.
in 2 minutes why I'm not laying much of credence on beta. Is it okay?
Yes,
Yes.
sir.
Okay, sir.
Now what I ask you is to establish this wave. Let us try to understand what will happen when I take a string which is being fixed at both the ends. Let us try to understand what will happen when I take a string which is fixed at both the ends. And what I do, I am plucking it continuously, incessantly. Is it okay? What I am doing to the string, I am plucking it. Incessant, unwavering pluck. Is it okay, dear?
Yes, sir.
I'm plucking it unrelentingly. If I'm plucking it unrelentingly, am I not generating a wave?
Yes,
Yes.
sir.
Yeah.
Yeah. Yes, sir.
Am I not generating a wave? Yes or no? All of you, please.
So you
Yes,
are.
I
sir.
am
Yes.
generating a wave, correct, dear?
Yes,
Yes,
sir.
sir.
That wave reaches wall. Let us say one of the pulse that I am generating, it reaches wall. What will happen? Wall will do a source. Agreed or not?
Yes, sir.
Agreed or not? We have studied in reflection. Try to
Yeah.
recollect here.
Yes,
We
sir.
have
Yeah.
studied in reflection. Try to recollect. Wall does a source, correct?
Yes,
Yes,
sir.
sir.
What will wall do? Wall will generate another wave. One wave trail is generated by me and the other wave trail is generated by wall. Agreed or not?
Agreed, sir.
Yeah.
And they will get superimposed where? On the string. Agreed? They will
Yes, sir.
get superimposed where? On the string. Agreed or not?
Agreed,
Yes,
sir.
sir.
If they get superimposed on the ring, then we can write equation as 2a sine kx plus minus beta by 2 cos omega t plus minus beta by 2. Agreed?
Yes, sir.
Sure, all of you. Say me yes or no. Be affirmative indoors if you are good. If not, ask me questions. Is it okay?
Yes,
Yes,
sir.
sir.
Okay. Now let me write x is equal to 0 for this end and x is equal to L for this end. Is it okay?
Okay, sir.
Now tell me, irrespective of whatever time you are reading the situation, irrespective of whatever time you are reading the situation, this situation, is it okay? Irrespective of whatever time you are reading the situation, at x is equal to 0, displacement of particle will always be 0.
Yeah. Yes, sir.
Yeah.
Yes or no? Why? You have fixed x. Say me yes or no, dear. Endorse
Yes, sir.
me.
So
Yes,
agreed, sir.
So
sir.
whatever time, take whatever value of omega t. Take whatever comes to you, omega t, whatever time you do. One thing I'm sure of, that if I place over here x is equal to 0, then I should get zeta 0, correct?
Yes, sir.
Yeah.
Agreed or not, all of you?
Agreed, sir.
Yes, sir.
Okay. In that case, tell me, if I place x is equal to 0, then I get sine of the angle beta by 2. And since I have told you it is independent of omega t, so you can place whatever time, I should get left of the equality 0, correct?
Yeah. Yeah.
Yeah.
Yes, sir.
If left of the equality is 0, then sine kx plus minus beta by 2 must be 0. Because it is independent of time, same yes or no? Think about
Yeah.
it.
Yes,
Think
sir.
about it. Time has got nothing to do over here. Reason for the it being, if I take omega t, let's say I take omega t 0. Okay? I take omega t 0. Take one value of time, 0. Right? Yeah?
Yes, sir.
Yes,
What
sir.
do I
Yeah.
get from the equation? Think about it. I take omega t 0. Any one time Krish. Is it okay?
Yes, sir.
What I get? I get 2a sine of the angle kx plus beta by 2 into cos of the angle beta by 2.
Yeah. Yes, sir.
Now this
Yeah.
is non-zero. Let's say this is non-zero. Is it okay?
Okay. Yeah. Yes, sir.
But I want to the left of equality get me a 0, correct?
Yeah. Yes, sir.
When will I get 0 to left?
When kx
I want
sine
it to be
theta is
established when x is equal to 0. So what I get? It should be 0. So 2a sine beta by 2 must be 0. Agreed?
yes, sir.
Yeah.
Which makes beta. Which makes beta. Come on,
0
tell me. It's one value of
The
beta.
beat.
What do
0
we get beta as?
and 0 or n pi.
So what we say, one value, let's say 0, right there. So what do we
Yes, sir.
get to see from here? Beta will be 0 for the case at hand. Agreed?
Yes, sir.
Yeah.
For the case in disposal, for the case at hand, beta will be 0. So if beta is 0, which is what I was harping on, tell me what is the final equation vis-a-vis the experiment under study. And what that experiment? Both the ends are fixed. Clear?
Yes,
Yes.
sir.
Both the ends are fixed. We end up getting 2a sine kx cos
omega.
of the angle omega t. Correct?
Yes, sir.
Yes, sir.
Oh, good enough. So this is our equation.
Standing line.
And
So this is
just to get us what pattern? Because they being all mathematics, as of yet we have dealt logically with what will it shape to, but we have not proved it. Mathematically in black and white we saw. Now let us factor in physics to it. Is it okay?
yes, sir.
Okay.
Yeah.
Plot for t equal to 0. Okay, take a time. Write down. Let us take t equal to 0. Let us take t equal to 0 and plot for equation 1. Let us take t equal to 0 and plot for equation 1. Now, this is equation 1 to us. I'm plotting it for t equal to 0. So what do we have at hand? We have, now t being 0 place, we get from here 2a sine of the angle kx. Agreed?
Agreed, sir.
Okay. We have to plot for it. So let us plot for it. 2a sine kx. We get it varying with x, correct?
Yes, sir.
Yeah.
X is equal to 0, 0, then it increases and then decreases for the other value. Which one? As Krish was indicating, I'm going by it. Is it okay, dear? 2a sine kx. You know where will it be 0 again? First 0 will be at x is equal to 0. First 0 will be at x is equal to 0. And second 0 will be at x is equal to L. I'm talking of the same string. Got it, dear?
Yes, agreed.
Yeah.
Yes, sir.
So 2a sine kx. Good enough. Now look at the term 2a sine kx and tell me, for what values of kx? I repeat, for what values of kx or x, 2a sine kx will be maximum. When will 2a sine kx? Look at this equation. Look at this equation. This equation is function of x and function of time both. Agreed?
Yes, sir.
Yeah.
Yes, sir.
First part of it, which is 2a sine kx, depends on x, correct?
Yes, sir.
Yes.
And first part of it gets you the amplitude. Getting it there?
Yes, sir.
Yes.
First part of it gets the amplitude. That means what is 2a sine kx to indicate? 2a sine kx is indicating amplitude. Amplitude of what? Amplitude of pattern which we are to study. Mathematically studied, now on the physicality of it. Got it, yeah?
Okay, yes, sir.
Yeah.
What is 2a sine kx? 2a sine kx is the amplitude part as it varies with x. So it is function of x. And the other part is function of time. Got it?
Yes, sir.
Yes, sir.
Okay. Now I have frozen time. Time has been frozen, right? Yeah.
Yes, sir.
We are studying for what time? For t equal to 0. So when t equal to 0, we get cos omega t 1. Thereby we are left with 2a sine kx in solo. Unilaterally, 2a sine kx is to decide displacement. Correct?
Yes, sir.
Yes, sir.
Now tell me, where will you see 2a sine kx getting its maximum value? That means, where will you see 2a sine kx attaining what value? 2a
So when
value, right? Yeah.
yes,
Yeah,
sir.
so that means
So
Yeah.
when
Maximum
kx is equal to
kx will
pi
be what?
or
Yeah, what will it be? What will be the maximum of 2a sine kx? Will it not be
so
2a?
yes, sir.
Yeah.
yes,
Yes,
sir.
sir.
Yeah.
Get to see from here sine kx is equal to what for us is plus minus 1. Why
Yeah.
plus minus? You know, all
Yeah.
of you
Yeah.
do. Correct? Yeah.
Yes, sir.
Yes, sir.
Yes,
Yes.
Yeah.
sir.
Yeah.
Yeah.
Yes, sir.
Tell me what will be kx. Kx
So
will be 2m plus minus 1 into pi by 2. Agreed?
Yes,
oh,
I agreed.
yeah.
In, if this is to be further, what we will get is 2 pi by lambda, as that is what is replaced for k, into x is equal to 2m plus minus 1 into pi by 2. Are you known to k being replaced by 2 pi lambda or lost on
Yes,
it?
sir. We know.
Yes, I remember, sir.
So, gone. What do we get to see from here? Please see for yourself. What is x equal to? 2m plus minus 1 into lambda by 4. A very important relation this. X is equal to 2m plus minus 1 into lambda by 4. Now deciphering this equation. This equation indicates that wherever we get x in adherence to this equation, there I will find amplitude to be a maximum. Agreed?
Yeah.
Yeah.
Yes, sir.
That is the place which is being technically termed as displacement antinode. Got it? Yeah.
Yes, sir.
Yes, sir.
What is being termed as displacement antinode. So what are the positions where we will get displacement antinode? We can get from here. Getting it here?
Yes, sir.
Yes, sir.
Am I clear with this one? Think about it. Is it fine?
Yes, sir.
Yes,
Agreed.
sir.
Okay. So x is equal to 2m plus minus 1 lambda by 2. Tell me where will we are getting displacement node? Where will I be getting displacement node? Any one of you? What will I do for displacement node? What will I equate to a sine kx to? Mind you, in your case, a1 is equal to a2. And I have made you bracket that term. If a1 is equal to a2, then displacement node will get you 0
Zero.
deviation.
Yes, sir.
Yeah.
Yes, sir.
Yes, sir.
What we get from here?
Yes,
Kx
sir.
is equal to what we can say m pi.
N pi. Yeah.
If kx is equal to n pi, then 2 pi by lambda into x, same, exactly the same, is equal to m pi, pi and pi gone. X is equal to m pi, m lambda by 2, correct? Yeah.
Yes,
Yes,
sir.
Another
sir.
relation. And this one is indicative of which points? This
Displacement
one
node.
is indicative of displacement
Node.
nodes, correct?
Yes, sir.
Displacement antinode and displacement nodes being known to you. Correct? Yeah.
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay, now I take a general case. First I take a general case and then I'll come back to the case at disposal. General case for your understanding. A general case. Wire being given to you, you want to see pattern of wire. Wire being handed over to you, standing wave formation being exhibited by wire. You want to see the pattern. And pattern you want to see at what time? T equal to 0. What you get to see? You get to see this pattern. And this pattern, why I am marking this pattern? Is because now is known to you where will be node, where will be anti-node, right?
Yes,
sir.
sir.
So at x is equal to 0, you got node. Agreed or not?
Yes, sir.
Okay. Then next node, because
Yes,
node equation
sir.
is there with you here. Node equation is there with you. M lambda by 2. Agreed?
Yeah.
Where M is 0, plus minus 1, plus minus 2, so on and so forth. Right, dear?
Yes, sir.
So now tell me, you got it at 0. Next will be at lambda by 2. Agreed?
Yes, sir.
The other node, where will you get the other one? Tell
Lambda.
me.
At 2m
At
plus.
where? At lambda you get another. General case. General case. Good enough. Now, antinodes, they are also known to you. And they position at plus minus 1 into lambda by 4, correct?
Yes, sir.
Yes, sir.
Now, one symbol plus and take m equal to 0, correct?
Yes, sir. So
What
it
do you
will
get
Yes.
lambda by 2? M equal to, what did I say?
so you get
Lambda by
lambda
4.
4. This was 4.
Yeah.
So what do we get? Lambda by 4, m equal to 0 and plus sign, correct? Yeah?
Yes, sir.
Yes, sir.
So we get lambda by 4. This is the formula, lambda by 4 it is. So this is where we are getting displacement. Displacement maximum, which is called displacement antinode. Is it okay?
Yes, sir.
Antinode. You also call nowadays anti. So this is displacement antinode to us. And accordingly, we can say for the other one as well. When we will place m equal to 1. Correct, yeah?
Yes, sir.
Yes, sir.
So you got this. You got this pattern exhibited at what time? T equal to 0. Agreed?
Yes, sir.
Yes, sir.
Okay. Back to the basic. This is the basic equation. Don't lose sight of the basic equation. We are plotting for this. Correct? Yeah.
Yeah.
So T equal to 0, we got this. Let me also ask my mathematics students that what is time period of this function? 2a sin kx cos omega t. What is time period? Time period means it should repeat its value in its entirety, in toto. So tell me what will be time period. Yes, Krish, you said something.
So for sin kx, it will be 2 pi by k. But for cos
Yes,
omega,
time period. Time period will relate to time, not x. Time period will relate to time, dear, not x. What is
2 pi.
time period?
So we freeze the position, right? And we take cos omega t.
We are taking t equal to 0. Of course, at t equal, if you freeze position, it can never return, right, Krish?
Yes,
Yes.
sir.
So
Okay.
time period means what is the time taken to return. So it will not be governed by x, it will be governed by time, correct?
So will it be 2 pi? Like
2 pi
periodic?
omega. Yeah, no, Krish, this is not going right. This is not going right on mathematics, Krish. It is 2 pi by omega, cos omega t. Cos omega t will have that period of 2 pi by omega, correct?
Yes, sir. I understood for cos omega t, but why not kx the same?
How can
I
kx be deciding on time period? Yeah.
okay. Yeah.
Kx means what, Krish? Kx means it is varying with x when you have frozen time, right? I told
Okay.
you that there are two functions over here, one varying with x and the other varying with time.
Time.
You
Okay. Yes, sir.
want your string back to the same orientation. And that will be back to the same orientation if and only if you invest on time, right? Yeah.
Yes, sir. Yes, sir.
So time period is governed by time function, not x function, correct?
Okay. Yes, sir.
What time it will be back to this position? It will be back to this position in what time? In time 2 pi by omega. What is time period for a function? When function repeats itself in all fronts.
Yeah,
Correct?
yes, sir. Yes, sir.
So hereby in all fronts I mean velocity, acceleration and position. Correct?
Yes, okay, yeah. Yes, sir.
So it will be back to this shape after what time? After time t pi by 2 pi by omega, which I'm marking as capital T. Is it okay?
Yes, sir.
And now to see what happens after t equal to 0. This is for t equal to 0, this function plot, correct?
Yes, sir.
Yeah.
Now you take t equal to capital T by 4. Clear?
Yes,
What
sir.
t value? Small t. Small t equal to how much? Capital T by 4. That means capital T removed by 2 pi by omega. Correct, yeah?
Yes, sir.
Yes, sir.
Then by 4. What do we get? Pi by 2
Five.
omega. Correct?
Yes,
Yes, sir.
sir.
Place the value of small t here as pi by 2 omega. Place it. Small t is pi by 2 omega. Place it. Tell me what you get to see.
Pi cos pi by 2, which is
Which is, what is cos pi
0.
by 2?
Zero.
Finish.
Zero.
0.
So
Zero.
cos pi by 2 0 means zeta will be 0. Correct?
Yes, sir.
Yeah.
That means this string will now shape a line. It will be shaping a line. Agreed or not?
Yes, sir.
Everywhere displacement of particle is 0. So what will happen to it? It will become a straight line. Same yes or no? Check it here.
Yes, sir.
Yes, sir.
Now you take t equal to capital T by 2. Take t equal to capital T by 2. And tell me what you get. Again t 2 pi by omega and then 2 as it is. What do we get from here?
We'll get
Pi by omega, correct?
omega. Yeah, it will be -1.
Take it over here. Negative of the previous, negative of what we began with, correct?
Yeah, so it will be maximum displacement downward direction.
So it goes this way. Negative of what we began with, correct? Yeah.
Yes, sir. Yeah.
So it goes this way. This is the plot for t equal to capital T by 2, correct?
Yes, sir.
Yes, sir.
And then we increase it further by t by 4. That means for t equal to 3t by 4. Again, it will be a straight line. Check it out.
Yeah, you'll get 0. Pi by
3t
2.
by 4, again it will be 0. Please do check. Here, small t equal to capital 3t by 4. You can place and see for yourself. You'll get again 0. Correct? Yeah. Semi yes or no?
Yes, sir. Yeah. Yeah, you'll get 3 pi by 2
Then when
omega.
you are back to small t equal to capital T, you will be back to initial position, right?
Yes, sir.
Yeah.
We saw for how many cases? 1, 2, 3, 4, 5. Correct?
Yeah.
Yeah.
Yes.
But there are infinite moments in between them. Correct? Yeah.
Yes, sir.
Yes, sir.
In between any two moments. Between any two moments. Let's take the terms between any two moments. Between any two moments, there can be infinite moments. Correct? Yeah.
Yes, sir.
Yes, sir.
You can plot for all such times. See how it is changing. Then this. Then a straight line. Getting it here. Please be careful. You'll not be getting anywhere. Then a straight line. Then this goes down. This goes up. Got it? Then
Yes,
this
sir.
goes further down. This goes further up. Correct?
Yeah. Yes.
Yeah.
This is how it is changing its curvature. Is it okay? This is
Yes, sir.
what happens. You will not be able to notice it in this distinction owing to persistence of vision. Got it there?
Yes, sir.
Very fast rate. So what appears to you when you plug a rubber band is a loop formation. Agreed?
Yes, sir.
Yes, sir.
And that is the loop which I am studying for. Do we actually get loop? Of course not. For different position, different timing, you will get different curvature. Tell me yes or no?
Yes, sir.
Yes, sir.
That is exactly what we are studying for, dear. So we can say that we have seen the pattern. This is displacement node, this is node, this is node, and they are displacement antinodes. See for yourself, one node is sandwiched between two antinodes, or one antinode is sandwiched between two nodes. Correct, yeah?
Yes, sir.
Yes, sir.
And that is what we have. What will be the distance between two consecutive nodes known to you? Because you know n lambda by 2 and 2n plus minus 1 into lambda by 4. Correct, yeah?
Yes, sir.
Yes, sir.
So we know distance between two consecutive nodes or two consecutive antinodes, or for that matter, between a node and antinode. Can you tell me?
Sir, for between two nodes, it is lambda by 2, or between two antinodes also is lambda by 2, and between node and
Yes.
antinodes, lambda by 4.
Yes, good, Krish. So that is what we are getting over here. We'll be making good of it in the next deliberation. Please take a note of positioning. Is it okay to all of you?
Yes, sir.
Yeah.
You get to how will it vibrate?
Yes, understood.
Okay, now back to what I did begin with. And that being, write down. Let us take a string with both the ends being fixed. Let us take a string with both the ends being fixed. So I'm taking a string here which is fixed at both the ends. That is what we began with, by the way. We are back to it. Fine here.
Yes, sir.
And we want to vibrate this string. We want to vibrate this string. So the moment I'll say I want to vibrate this string, you will think of frequency, correct?
Yeah.
The moment I say that I want to vibrate this string, then you will ask, okay, what must be the frequency then? Because frequency must be attributed to any vibration. And we are coming from simple pendulum, remember? 2 pi under root of L by G, remember or not?
Yes, sir.
Yes, sir.
So simple pendulum has got only one frequency to its merit. Simple pendulum has got how many frequencies to its merit? Only one frequency. It can vibrate in only one frequency, and that we get from our understanding of 10 syllabi 2 pi under root of L by G. Correct, dear? Remember or forgotten or not taken ever?
Yes,
Sir,
sir.
sir, is there simple harmonic motion, sir? We have done
That
that.
was so we know from there as well. Therefore, we can say that this is the time period, and accordingly we can get omega. There is only one omega which it relates to. Correct, yeah?
Yes, sir. Yeah.
Yeah.
Now here we take a departure from that understanding. Here we take a departure from that understanding. And why I am into taking a departure from that understanding? String that we are into referring here can vibrate in n modes, many a mode. Is it okay? It can vibrate in how many modes? It can vibrate in n modes, you say, or you say it can vibrate in many a mode. Is it okay?
Yes, sir.
Yes, sir.
So you can attribute to it multiple frequencies. Got it here? Very important distinction. You can attribute to it how many frequencies? Multiple frequencies. Got it?
Yeah. Yes,
Yeah.
sir.
And the minimum frequency or the threshold frequency is called fundamental frequency. Yeah. The
Yes.
minimum frequency with which it can vibrate, which is also called threshold frequency, is fundamental frequency named technically. Is it okay? Threshold,
Yes.
threshold is the beginning, right? Yeah. Threshold of anything is the beginning. The threshold is more of English to be related. We call technically it fundamental frequency. Got it?
So, one doubt. So,
Huh.
will fundamental frequency be the natural frequency of the string?
Fundamental, no, it's not natural. Natural is different here. Natural is even if when it is not into vibration, there is some vibration which you will have to attribute to it. So the vibrations that we are talking of, Krish, they are all force vibrations.
Hmm.
Okay?
Yes, sir.
Sir, I've
They're not, we have plugged it, right, Krish?
Yes, sir. We have plugged it. Yeah.
So that is not natural. Natural vibration we are all into. And you know that, isn't it?
Yes, sir. Yeah. Yeah.
Sir,
Yes.
I have heard of threshold frequency from chemistry, atomic structure, sir. Photoelectric effect. Is it the same?
No, it's not the same. There you related with modern physics, which is related to photons. So photons when hit, it can dislodge electron provided there is some minimum energy which is as per the atom on which it is bombarded decided. Okay?
Yes, sir.
So that is called threshold frequency because frequency there is to decide on energy, hc by lambda.
Yes, sir.
Okay, or h mu. Mu is frequency there. Mu is written as c by lambda. So that is
Yeah.
different ball game. Over there, we relate it to energy, and that energy is minimum. Of course, threshold means the same. Threshold means minimum, beginning.
Yes, sir.
Okay, if the energy is less than threshold energy, or if the frequency is less than threshold frequency, electrons are not to get dislodged. You will not get to see photoelectric effect.
Yes, sir.
Okay. So over here, what we are to see? We are to see that there are n modes in which string is set to vibrate or can be set to vibrate. Correct?
Yes, sir.
Yes, sir.
The minimum that we require is called threshold frequency. Clear, dear? Or
Yes, sir.
fundamental. Technically fundamental. Now let me ask you. This is to me a string which has got both the ends fixed. X is equal to 0, X is equal to L. Got it, yeah? So what is
Yes,
length
sir.
of string? L. Length of string is L, correct?
Yes, sir.
Yeah.
I want it to set in vibration. I want this to vibrate. And I want this to vibrate with minimum frequency. Got it, yeah?
Yes, sir.
Yes, sir.
So minimum frequency will correspond to maximum lambda wavelength.
Yeah. Yeah.
Yes,
Yes, sir.
Madhav?
Yes, sir.
V is
Yeah.
equal to F lambda. We know that, right? Yeah.
Yes,
V
Yes,
is
sir.
sir. Yeah.
same because medium is same. T and mu are not changing. So V is same. So what we are to say over here? If
We.
F is minimum, lambda should be maximum. Correct?
Yes,
Yeah.
sir.
Can you tell me when will this string or how will this string exhibit maximum lambda? Maximum value of lambda. When will lambda be maximum? Length is L. Length is L. I show you two lambdas. One lambda is this to me, and the other lambda is this to me. Got it? Yeah, lambda, wavelength.
Yes, sir. So it's the first
Yeah.
case, sir. First case.
So this is. Can we have a lambda bigger than this?
No.
Can you try get me a lambda bigger than this one? Of course, not possible. Correct? Yeah.
Yes,
Yeah.
sir.
So this is the largest lambda we can get. Agreed?
Yes, sir.
Yeah.
And from here to here, what is the length? L, correct?
Yes, sir. Yeah.
L
Yeah.
is depicting what part of wavelength? Lambda by 2, agreed?
Yes, sir.
Yes, sir.
Half of it. So what do we get lambda from here? Lambda is equal to twice of L. This is the
Yes, sir.
maximum lambda. Got it here?
Yes, sir.
Yes, sir.
Maximum lambda that you can get. Let us try to generalize it. You can see for yourself, maximum lambda also mean distance between two consecutive nodes, correct?
Yes, sir.
And what we can generalize it by? N lambda by 2. Check it out. Two consecutive nodes. What is the difference? What is the distance? Distance between two is lambda by 2. Consecutive, if I say then lambda by 2, correct?
Okay, yeah. So yeah,
And
yes
it's
sir.
getting simple solution than n lambda by 2. Say me yes or no?
Yes sir, yeah.
So I'm generalizing it. What we can say, n lambda by 2 is equal to L. L was the length.
Yes sir.
So lambda is how much to us? Lambda is twice L by N. A very important formula you will not get. So write it down the way that I'm writing and try to comprehend it. Lambda N is equal to twice L by N. I have marked it as lambda N, where N means the order. Where N means the order. Place N is equal to 1, you get the first order. We call it first order harmonic or fundamental frequency. Got it, yeah?
Yes sir.
Lambda equal to n equal to 1, so lambda equal to 2l. If lambda is equal to twice of length, then we are getting first order harmonic, or we can say fundamental frequency mode. Correct, yeah?
Yes sir.
If n is equal to 2, second harmonic. N equal to 3, third harmonic. Is it okay? So n over here is the order. What is
Yes
n
sir.
over here? The order. Place n equal to 2 there. Just to see. Place n equal to 2. So second order,
Yes
what
sir.
we get to see? Twice of L by 2, which is equal to L. Correct?
Yes
That
sir.
is being shown on the board. It is already there on the board. Check it out.
Sir, can we generalize like this? If the order is n, there'll be n plus one nodes.
N plus 1 depends on which ones you are taking here. You can go ahead. If you take 1, 2, 3, you can go ahead. I'll be coming to it, dear. Don't worry. I'll make you vis-a-vis node study. Okay, dear? Vis-a-vis node, vis-a-vis loop, everything. Okay, dear, Krish?
Yes sir.
Okay. So for now, if n is equal to 1 loop. Can we say? If n is equal to 1 loop. Can we say that?
Yes sir.
We get 1 loop. If n is equal to 2, we get 2 loops. Correct?
Yes sir.
If n equal to 3, we get 3 loops, so on and so forth. Correct?
Yes sir.
Okay, so that is what we are getting. And remember this formula, twice L by N, where N is the order. And accordingly, frequency I ask now. What is frequency? V by lambda, correct?
Yes sir.
And what is V? V is T by mu. You remember?
Yes sir. Yeah.
I'm writing V over here now. For now, I'm writing V and lambda 12. So N goes up and 12 goes down. Check it out here.
Vn by 2l.
Yes. NV by 12. Read it as NV by 12. Is it okay?
Yes sir.
NV by 12, where V is the speed and N the order. Is it okay?
Yes sir.
Yeah.
Fundamental frequency means N is equal to 1. Correct?
Yes sir.
What does fundamental mean? N equal to 1. So that will be V by twice L. Write it down. Fundamental frequency relates to N equal to 1. Fundamental frequency relates to N equal to 1 and is equal to V by twice L. Got it, yeah?
Yes sir.
Yes, sir.
Okay, good enough. Now we go for a term. Firstly, I have made you understand what are harmonics. Is it clear?
Yes sir.
What are harmonics? Tell me. Harmonics are simply whatever you are multiplying with fundamental. Check it out. Fundamental is this V by 12. It is multiplied with N. So N will get you the harmonic. Is it okay?
Yes sir.
Yeah.
Is it okay? Whatever is N, that is in a way harmonic to you. Am I clear on this? This is very important. Whatever is
Yes
N,
sir.
to read the harmonic. Yes, dear.
Nothing sir. I agree. It's nothing.
Okay. Now, can you plot for third harmonic? How many
Sure.
loops you will get for third harmonic?
The three loops.
3 loops.
Is it okay? So third harmonic.
Yeah.
Are we getting all the harmonics over here? 1, 2, 3, 4, 5, 6, all? Yes or no?
Yeah.
Yeah, yes, sir.
Yeah, yes, sir.
Please underscore this point. Please underscore this point that we get to see all the harmonics. All the harmonics are present. All the harmonics are present. Okay, good enough. So all the harmonics are present. It can vibrate in multiple frequencies. Correct, dear?
Yes, sir.
Okay, good enough. Now we introduce a term which is called overtones. Write down. We introduce a term which is called overtones. Now, what are overtones? Write down. Overtones are frequency marked. Overtones are frequency marked on scale barring the fundamental. Overtones are frequency marked on scale barring the fundamental. So let me spare the fundamental. Okay, dear? Let
Yes,
me
sir.
spare which one? Fundamental. How many harmonics we have? How many harmonics we have now? First being removed. So we have 2, 3, 4, 5. Right here.
Yeah.
Yes, sir.
So second harmonic will be read first overtone. Third will be read second overtone. Fourth will be read third overtone. Fifth will be read fourth overtone. Got it, yeah?
Yes, sir.
This is what we mean by overtone. Clear? Please be
Yes,
very
sir.
careful. The reading may change when you go to the other string formation. This is true for the string which is being fixed at both the ends. Got it?
Yes, sir.
Okay. So this is for one case. Case 2. Write down. If one of the end of string, if one of the ends, make it, if one of the ends of string is free, if one of the ends of string is free, so of the two ends, one is free. Is it okay?
Yes, sir.
Of two ends, one is free. I ask you the same question yet again. And that being, if one end is fixed, the other free, then what can be the maximum lambda representation? Maximum lambda. When you will get maximum lambda? Length remains the same. Length is L. Length is L. Which will get you the maximum lambda. Is not the one shown on board to get you maximum lambda? Check once. Lambda means to us. Lambda means to us completion.
Okay.
Okay?
No, sir. I don't understand how this case.
Lambda means to us completion here. This is lambda. From here to here is lambda, correct?
Yes, sir.
You want Ln to record maximum lambda. Ln should get you maximum lambda. Same what you did in the previous case. There
Yeah.
you showed this as maximum lambda because you are not having liberty to go beyond it. Reason? Both the ends were fixed, correct?
So, but in this case, shouldn't it start from the origin? Like, shouldn't it be at the
The
vertex?
origin only, Baba. This is x is equal to 0 only. And this end is free. This
Okay,
end is free. Is it okay?
yes,
So
sir.
in
Yes,
the
sir.
previous case, this end was fixed. So you had no option but to fix these points. And this orientation was getting you maximum lambda, right? In the previous case, you have seen, correct or not?
Sir, I thought it's above. It's at distance above, so that's why I took it wrong.
This is this one. Now we can exercise some liberty here. Why? Because this end is open, correct?
Yes, sir.
What we can do, we can say, okay, this is fixed. Now I want to maximize my lambda. So what will I do? I will treat this part as representation of length. See for yourself. This part as representation of length will get you maximum lambda. Check it out. Can you get a lambda greater than this? Because this is telling you that lambda by 4 is by L represented. Yeah?
Yes, sir.
Lambda by 4, lambda by 4, lambda by 4, lambda by 4. Total will be lambda. Correct?
Yes, sir.
This is which part of lambda? This is lambda by 4. 1/4 of lambda. Correct?
Yes, sir. Yeah.
And then we say lambda is equal to how much? 4 times L. Correct?
Yes, sir.
Can we get lambda more than this? If you get lambda more than this, I don't have any qualms. Then I will take that value of lambda. Because for frequency to be minimum, lambda should be maximum. Right, yeah?
Yes, sir.
So what can we say? Can we get a lambda greater than this? Check it out.
No, sir.
Get a lambda greater than this. This is the maximum lambda gettable, right?
Yes, sir. This is the maximum. Yeah.
So minimum frequency will read V by 4L, and this is what is threshold or fundamental frequency, correct?
Yes, sir.
Now tell me, distance between node and antinode, what you wrote?
The lambda by
Distance
4.
between
No.
node and antinode, 2m plus minus 1 into lambda by 4, correct?
It's lambda by 4. Yes, sir.
Okay. Now this is equal to what to you? L to you. I'm generalizing it. Clear?
Yes, sir.
So what do we get from there? The general formula. Lambda is equal to 4L divided by 2M plus minus 1. Got it?
Yes, sir.
This is for which case? When one end is fixed, the other open. Right? Yeah. Yes, Adish, Pratyush, and Vedant. Respond, yeah.
Yes, sir.
Yes, sir.
Now look what I do. There I wrote lambda m. Here I am writing lambda 2m plus 1. You can take any symbol. I am comfortable with plus, so I am going with plus. Is it okay? What do we get over here? 4l divided by 2m plus 1. Correct?
Yes, sir.
And when I am comfortable with plus, I'll get you know. If I place m equal to 0, I get lambda 1. Correct?
Yeah. If you put n is 0, if it's minus, you'll get minus 1 then.
Yeah, then you'll get minus. So that's the reason I'm going with the plus sign. So lambda 1 means how much to us? 4L, correct? Check it out.
Yes, sir.
Now you put m equal to 2. What do you get? When you put m equal to 0, you got lambda 1, correct? M equal to 1, you get lambda 3. Check it here. First
Yes,
m equal to 0, you got lambda 1, correct?
Yes, sir.
You can take minus also. Then you will get m equal to 1 as lambda 1. Is it okay?
Yes, sir.
Whatever comes to you, you can go ahead with it. Let me write that as well. 2m minus 1. If I am going with 2m minus 1, then I get 4l divided by 2m minus 1. And to sum, 2m minus 1 will be more to gel than 2m plus 1. Tell me why. Here m equal to 0 is getting you lambda 1. Here m equal to 1 will get you lambda 1. Correct?
Yes, sir. Yeah.
So whichever comes to you, you can go ahead with it. Now tell me. Second, m equal to 0, lambda 1. M equal to 2, m equal to 1, lambda 3. How much is lambda 3? 4L by 3. Agreed?
4L by 3. Yes, sir.
Now m equal to 2. What do I get?
Lambda.
Lambda 5. Correct? How much
Yes.
is lambda 5? 4L by 5. Check it here. Check all of you.
Yeah. So lambda n is 4L by n.
4L by
N.
lambda what?
So lambda n is equal to 4L by n.
There is nothing as lambda n. Lambda 2m plus 1. It is not lambda m. Lambda 2m plus 1. Okay, 2m plus 1 is the order. Lambda n was for both the ends fixed.
Okay, sir.
This entire term is to be read. This entire term is to be read. There the order was given by m. Here the order is given by 2m plus 1. This is the order. Got it here?
Yes,
This
sir.
is the order. Okay. What is 2m plus n? Or 2m minus n? That is the order. Got it, yeah?
Yes, sir. Yes, sir. Got it.
Okay. Yes, Adesh, tell me the fundamental frequency equation. How will I write general frequency, not fundamental? Fundamental is written. General frequency equation. How will I write? Tell me, Adesh.
So V is V by 4L.
V by lambda. And lambda, you have a formula. 4L, okay?
4L, so or V into 2M plus 1 by 4L.
Okay, fine. 2m plus 1, 2m minus 1, whichever you take, accordingly, you have to write over here, correct?
Yes, so 2M minus 1 is better, yeah.
So V mu 2m minus 1 is equal to, I'll write 2m minus 1 first. 2m minus 1 into V by 4L. Okay?
Yes, sir.
Okay? 2m minus 1 into V by 4L. This is for which case the formula? This is for the case when one of the end is open, correct?
Yes, sir.
One of
Yes,
the
sir.
end is open. Yes, yeah? Yeah.
Yes,
Yeah.
sir.
Yes, sir.
Okay, get me now. Now tell me, Vedant, it goes to you now. Tell me, Vedant, are we getting all the harmonics? How do we get the order of harmonic? By 2m minus 1. Got it, yeah? 2m minus 1 or 2m plus 1. Correct, yeah?
Yes, sir.
And m over m mathematically is 0 plus minus 1 plus minus 2 plus minus 3. Correct?
Yes, sir.
So tell me, are we getting all the harmonics? And I told you what do I mean by harmonics. Harmonics means whatever is multiplied with fundamental. Correct? This is fundamental.
Oh, yeah, yes, sir.
What is harmonic over here? 2m minus 1. 2m minus 1 or 2m plus 1 is harmonic to us. Correct?
Yes, sir.
Are we getting all the harmonics? Or there are a few missed?
So there are few miss.
Okay, which ones are the missed? Can you identify?
2m plus 1.
Which ones are the missed? M is 0 plus minus 1 plus minus 2. Pratyush, which ones are the miss?
Just a second.
Which ones are the miss? Come on, it's very simple from here to get. Which ones are the miss, Vedant? 1 is present here, 3 is present here, 5 is present.
Sir,
Correct, yeah?
yes, sir.
So, 2 is a miss, 4 is a miss, 6 miss, so on and so forth. Correct?
Yes, sir. So, yeah.
So, we see all the
No,
even harmonics.
even one, sir. Yeah, even one.
All
Yes,
the
sir.
events are a miss. Only we are to see the odd harmonic present. Write it down. So only odd harmonics are present. When one
Sir,
end is open, we see only odd harmonics being exhibited, not the even ones. Yes, Krish?
one doubt. So basically, odd harmonics means you get new one, lambda 1, lambda 3, lambda 5. So will
Yes.
lambda 3 be called the first overtone in this case?
Yeah, lambda 3 will be called first overtone and accordingly lambda 5 will be called second overtone. Okay?
Yes, sir.
Okay. That is what the case is. 2n plus 1 or 2n minus 1. Accordingly, you can place it. Right? Yeah.
Yes, sir.
Okay, this is the first harmonic. This is the first overtone. Third
Okay, yes.
harmonic in this case will be first overtone. Write that down as well. Third harmonic, first overtone, and fifth harmonic will be second overtone. Questions are asked on this directly. Direct questions being asked. They will not get you harmonic, they will get you overtone. From there, you can decode. Is it okay? In case both the ends were fixed, the relation was n and n minus 1, correct?
Yes, sir. Yeah.
Yes, sir.
So the relation is n and 2n plus 1, correct?
Yes.
Right?
Yeah.
Yes,
Yes.
sir.
Yes, sir.
That is the relation which we have, and accordingly we get to see the pattern. Okay. So this is the fundamental. After of this, how will it vibrate? It can vibrate in third harmonic, correct?
Yes,
Yes,
sir.
sir.
So third harmonic this way. Yeah.
Yes, sir.
And this one was for fundamental. Check it out here. Visible to all of you? Let me show it by different
Yes,
color.
sir.
This one is the representation of third harmonic. So third harmonic means one loop and the other half, correct?
Yes, sir.
Yeah.
And first harmonic means half a loop, correct?
Yeah. So nth
Clear?
harmonic 1/2.
Clear, dear?
Yes, sir.
Okay, so now you are to plot for fifth, seventh, and ninth harmonic and upload your working vis-a-vis both the ends being fixed and one end open. Got it?
So fifth, seventh, and ninth.
Fifth, seventh, and ninth. Okay?
Yes, sir.
Clear? Clear, all of you?
So what should be uploaded?
Yes, sir.
The drawing, the way it would look.
The plot will be uploaded on WhatsApp. Okay?
Yes, sir.
Okay. What's the time now?
So the time is 5:15.
5:15.
Yes, sir.
Okay. So this is for standing wave formation and different frequency which we have got. Now, we'll end the class with a very important question. Write down. There is a composite string. There is a composite string made of aluminium and steel. This is a Sivama question. Made of aluminium and steel. Rho1, L1, A1 and Rho2, L2, A2. Rho1, L1, A1 and Rho2, L2, A2 are the respective density, length and cross-sectional area. Are the respective density, length and the cross-sectional area. Find the ratio of N1 to N2. Find the ratio of N1 to N2. Hence derive a formula when this string is in unison with a tuning fork. When this string is in unison with a tuning fork. Now, in unison with a tuning fork, in consonance with tuning fork means that whatever is the frequency of tuning fork will be the frequency of composite string. Is it okay? Is it okay?
Yes,
Whatever
sir.
is the frequency of tuning fork will be the frequency of composite string. But the problem being, the string is made up of two wires, two media, right? Yeah. The string is
Yes,
made
sir.
up of two media, correct? It is not one medium. It is not one medium. Rather, is two media. Say yes or no?
Yes, sir.
So, what shall we do? How shall we go about it? A quick question understanding first. These are the strings to you. Rho1, A1, L1, Rho2, A2, L2. Got it? Now
Yes,
a tuning fork. Tuning fork is being so adjusted that the system is in unison with tuning fork. Is it okay?
Yes, sir.
Okay. Now I don't know how they are vibrating. I don't know how many turns will get formed over here and how many will get formed over here. Is it okay? That I don't
Yes.
know. Are you getting it? Where the question is coming from or stemming to? Getting it?
Yes, sir. Yes, sir.
We don't know how many loops are to get formed. Okay. because there are different mediums, so different number of loops. Let me say this is getting you n1 loops and this is getting you n2 loops. Is it fine?
Yes, sir.
Yes, sir.
Okay. Remember one, as not being told, if not said anything about junction, then we in general take junction to behave a node, to act a node. Is it okay?
Yes, sir.
Junction is to act a node, unless stated otherwise. Got it? If stated otherwise, then they'll get you displacement as well. Otherwise, you'll not be able to find out. Okay? So unless stated otherwise, junction, that means wherever the two lengths are to meet, that is taken a node. Is it okay?
Yes,
Yeah.
sir.
Now tell me frequency of first one. What we can write? N1 V by twice L. Remember?
Yeah. Yes, sir.
N1. And the second one? N2 V by twice L2. I'll write V1 here V2. Is it okay? Different medium, different speed, right?
Yes, sir.
Yes, sir.
So N1 twice of L1. And V is, as you know, T by mu1, correct?
Yeah.
And 2 twice of L2. And again V T by mu2, correct?
Yeah.
Yes, sir.
And mu1 can also be marked rho1 A1. Similarly, mu2, rho2 A2. Got it, yeah?
Yeah. Yes, sir.
Now you know how you can find N1 by N2, right?
Yes, sir.
Yeah.
Why I have kept tension the same? Tension will remain same through and through. Tension will not change. Got it? Yeah. If tension changes, then this point will start vacillating. Correct?
Yes, sir.
Yeah. Yes.
That is not to happen. Tension this side will be equal to tension this side. This is a very important formula. This gets you directly N1 to N2. Got it? Number of
Yes, sir.
loops in the first one to number of loops in the second one. This is, I think, the penultimate or third last question of SC Bama. Okay?
Yes,
Yes,
sir.
sir.
Okay, I'm keeping to this today. Fine, all of you?
Yes,
Thank
Yes,
sir.
sir.
you.
Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Sir, I had a
Yeah.
question, sir.
Uh,
Sir, do you know
say,
any good book for mathematics?
which topic?
Sir, just a general book in which there are questions and theory also is good.
No, there will be topic based set. This is suboptimal ask. You tell me the topic accordingly, I'll let you know.
Sir,
What do you mean by it?
so for like logarithmic inequalities or
Logarithmic equality, you get TMH. TMH you have? Tata Macro Hill?
T hem